Hello, good morning. Will and I were saying it's actually really great that we are up here on the top floor because it means anyone who braved the stairs to come see the talk must really want to see it. So that's great news for us. So thank you for making the time in the morning. We're really excited to kick off DDD with our presentation. But before we jump into it, we just wanted to say a huge thank you to all of the sponsors who helped to make today possible. And also to all the organisers and the volunteers who have invested their time to make this happen. Will and I especially are really grateful for how much DDD enables and supports first-time speakers like ourselves to be up on stage and give us that experience to be able to tell our story. So let's start with some introductions. So I'm Josh. I'm a digital designer with over 6 years of experience creating websites. I originally started as a developer, but then I decided I didn't want a career where I had to deal with people's annoying requests. So instead, I chose to be the person making those requests by being a designer. What that means is that I have a really strong understanding of the dev principles too, and I'm really passionate about bringing the worlds of design and code together.
Thanks, Josh. Yeah, I'm Will. I'm a front-end developer. I've been working as a dev for about 3 years now, mainly focusing on React and Next.js. Before that, I actually wrote something different. I wrote copy. I was a copywriter for about 5 years writing marketing campaigns. So I like to think I'm pretty good at naming things, which is obviously one of the hardest things to do in programming. Okay, Josh and I are a design dev duo from a digital agency called Southpaw. Southpaw is actually part of Reese, that's as in Reese Plumbing, Reese Bathrooms. We're part of Reese's Breakthrough Innovation Group. So we help the Reese team create websites and experiences that help them achieve their vision of being the trade's most valuable partner. But we also do that for external clients as well. We create websites and experiences for them. A bit about today, Josh is going to take us through a bit of a primer on atomic design, what it is, why it's great, and why it was a good fit for this project. Then I'll jump in and talk about code. We'll look at some of the technical challenges that we faced and some of the nitty-gritty details. Hopefully we won't get too lost in the weeds there. Then we'll both come back together and talk about that process of working together, collaboration, and bridging that design-dev divide, and what worked really well for us. And along the way, we'll leave you with some key takeaways that hopefully will help you in your projects. Josh, take it away.
Thanks, Will. I really love this room. What it feels like is that I'm giving a lecture at the front of a bus. I don't know where to look. But let's start with going through some context as to who Reese is and the background behind this project. So you may have heard of Reese. They are a key player in the trade and home space. And at their core, they really want tradies and small businesses to thrive in a digital world. Their website, as it stands right now, already attracts thousands of views. And that can be anything from a plumber who needs an urgent part for a fix to a homeowner planning their next bathroom renovation. That sounds simple enough, right? In practice, maintaining design consistency across this website is a bit of a nightmare. The Australian website alone features over 80 acquired brands, each with its own unique look and feel that they want to show underneath that Reese hero brand. Right now, that's spread across about 120 different CMS-driven pages, each of which are currently visually disjointed from one another. And that's just the start. Once you add in hundreds of stores and an overwhelming catalogue of products, things get a little bit messy. This is an example of every button style that we had prior to the introduction of this design system. My personal favourite, just there on the left, is the one that just reads Flushin'. Before Will and I could work with Reese and the rest of our team to solve these design issues, it was important for us all to understand just how extensive this problem was. So we partnered with another user research and digital design specialist agency called Slick. Over the course of a year, our two teams worked really closely together to audit Reese's ecosystem and deliver strategic recommendations for how to progress forward. Thanks to Slick's detailed analysis, together we built a strong case for a design system and defined the foundations together for how we could evolve our web components. Remember those 124 pages I mentioned? Well, Slick reviewed every single one in detail and confirmed what we all suspected. It was a bit of a no man's land. From colors to fonts there was no cohesion in the design across each page. Without rules or structure, every project we worked on felt disconnected and inconsistent. One thing became abundantly clear. We needed a design system. Fortunately for us, Reese were just as excited about this idea as we were, and their stakeholders were fully on board to give us whatever support and resources we needed to make this happen. We know that sometimes pitching the idea of a design system can feel like a bit of an uphill battle, but we were really fortunate to have such a progressive client that wanted to work with us on this. The question then became, how do we approach building a design system for a company this big? Enter Atomic Design. Before we talk about how we actually built the design system in Figma, I wanted to explain a little bit about the theory of atomic design and why we chose it for our approach. For those who haven't heard of it, atomic design is a design methodology invented by another web designer called Brad Frost. And it involves creating design systems and user interfaces in general by starting with the smallest elements and building up to the bigger picture. Here's what that means. When you look at a completed web page, we know that it's a collection of components stitched together to form a cohesive layout. Ideally, these are set up for reuse in a component library, but sometimes they're not quite flexible enough for us troublesome designers. So we try and stretch these blocks by making small tweaks. Maybe we'll introduce a new icon here or change the position of this element. These deviations, while they're quite small and trivial for us, they're major headaches for developers. Atomic design addresses this by breaking your design into the smallest parts possible to enable greater flexibility. You start by clearly defining stylistic foundations, your colors, typography, and spacing. These foundations inform the smallest reusable building blocks of your design, which are called atoms. These are things such as your buttons, your badges, and input fields. These atoms combine to form molecules, which are simple content structures, like a text block or a card. These, in turn, become components, the resultant blocks that we expect on a web page, like a hero banner or a carousel. This might be a little bit hard to visualize, so let's walk through an example together. We'll start with one of the smallest pieces in our design system, an atom. Here's an example of a button. It's something that's going to be used in multiple places across the site for multiple different purposes. I've outlined it in green so you can see how it's going to be carried forward and inherited as we move through this example. If we take this button and we now pair it with a headline and some body copy, we create a content block, which is an example of a molecule. This now gives that atom a purpose, where here it functions as a CTA for this block. You see the original green border of the atom, now joined by a purple one representing this molecule layer. Finally, we combine this molecule with another molecule, and we get a component, something that starts to resemble a finished design. This chain of inheritance becomes clear. From atom to molecule to component, each layer builds upon the last until you arrive at a completed UI. This atomic hierarchy ensures consistency throughout your entire design system. By focusing on smaller, reusable elements, you build a modular system that's flexible and scalable. Instead of creating a sprawling suite of components, you craft adaptable ones that can be refined at an atomic level. This creates a web of inheritance, where every piece is interconnected and cohesive, which is really great for us designers, and also for you, Will.
Yeah, I think from a dev side, we've probably all experienced a handover with the designer where you start working through the design file and you start noticing discrepancies in the wireframes where maybe a button border radius at the top left is different to everything else, and you wonder, is that intentional, or is this just a mistake that's crept in by not having solid foundations? So this hierarchy of building everything up from atoms really avoids that whole category of issues. So really helpful on the dev side.
Atomic design requires you to consider both the bigger picture and the smallest details. And you're often going to jump between the two to refine your approach. By focusing on the end result and the foundational elements simultaneously, you'll build a design system that's intentional and well organized. The parts define the whole, and the whole defines the parts. In our experience, atomic design's benefits extend beyond just visual consistency. By involving designers and developers at this foundational stage, we were able to align on design intentions and technical constraints. This eliminated guesswork, ensured the final output closely matched the designs that we did in Figma, and allowed us to rapidly design and deploy pages across Figma and Storybook, which Will talk about in a bit more detail soon. Atomic design didn't just help us create consistency, it really transformed the way that we work together. Let's talk about how we apply these atomic design principles within Figma. I mentioned earlier that our Figma space closely resembles the resultant Storybook components. That's not just about the visuals aligning, although shout out to Will and the rest of the devs for really nailing that. But what I'm talking about are the parameters and the variables that control these components. Jumping between Figma and Storybook, for the most part, feels seamless, with the same options presented on both sides. So we started by building strong foundations in Figma. Since we used Tailwind CSS as a base for our components, we didn't make our developers reverse engineer the styles and the classes that we used. Instead, we aligned directly with Tailwind CSS, working backwards from their existing values to provide a strong foundation for us to work from. We meticulously matched these variables to Tailwind's system. For instance, our spacing mirrored Tailwind scale for consistent element positioning, and our text styles use the exact Tailwind classes to remove ambiguity and get us speaking the same language. Here are some more examples. We set up a hero icon library that gave us one consistent source for all of our icons. We defined standard breakpoints for every common device from extra large to extra small, and we specified colors that were defined with very clear contrast pairings. How did you find working with this, Will?
Yeah, it helped massively to align so closely with Tailwind. We'll talk a bit about that when I talk about code as well. But having such a strong shared language, it was sort of the first building block, the foundation of building that language between the design teams and the dev teams.
Was this an early conversation between design and dev to agree on exactly this foundation?
We might answer questions at the end just to keep on track. But yes. With these foundations in place, we started creating the blocks as components in Figma. That's a bit confusing, right? We're talking atoms, molecules, components. Well, Figma treats everything as a component, which meant that we needed a clear labeling system to distinguish each distinct atomic layer from what your standard Figma component is. To do this, we organized each layer into its own space and clearly labeled the blocks that were yet to be designed, the ones ready for approval, and the ones that were about to start development. Moving forward, when I talk about a Figma component, I mean a reusable symbol that can be instanced within a design. But when I talk about an atomic component, I mean that final layer of a completed block that fits onto a web page. I hope that makes sense. Let's look at an example of how we actually set up these atoms in Figma with our badge component. We've set them up to try and be crystal clear for developers. Each block contains a detailed description as to what this component, or in this case atom, does, a link to its documentation equivalent in Tailwind CSS, and a well-structured visual representation of variations that show instance-level control. This helps developers like Will, as well as any other designer or anyone else working in the file, to see how these elements can be used, customized, and implemented. By placing these controls at an atomic level, we reduce complexity at the top of our hierarchy seen in modules and components. Instead of overwhelming parent-level controls with a multitude of options, we simplify that top layer, and instead, we spread the flexibility for inherited atoms. For instance, our button component has so many customization options, but they only become apparent once you drill down into that layer. Next, we have molecules. To recap, a molecule is a combination of different atom components to form a cohesive block of content. This molecule can maybe even contain other molecules, seen in this example where we have what we call a content block that contains a molecule of a button group, which consists of its own atoms. I know that I said that we kept complexity at an atom level, and looking at this molecule example, you might think that I was completely lying. But most of these options are actually just simply showing or hiding the atoms that have been inherited. They're not actually altering the properties of what's been brought in. Finally, we have components. Because these components are built purely from inherited molecules and atoms, each with their own display and stylistic controls, you should never need to break a component to make it work. It should be as simple as dropping in your content and styles, customizing it as needed, and everything downstream stays intact. By dispersing this complexity of each block through the idea of atomic design, we keep our components lightweight, reusable, and purpose-driven. Every component in our system has a unique role. They don't conflict with or double down on what other blocks are already doing. You might think that all this structure can make design a little bit boring, but it doesn't. As designers, our job is really to take these basic HTML blocks and bring them to life through creative intentions, clever layouts, and tailored content. It's not so much about feeling like we have to color inside the lines, but understanding the brushes and the pencils that we have to draw with. As a designer, if there's one key lesson that I took away from this project, it's to keep it simple. As I mentioned, there's a common belief that having constraints can limit creativity, but I disagree. There is great creativity in problem solving, working within constraints to create something beautiful that has also been streamlined and is feasible to build. For me personally, I learned that design systems don't have to be these massive, complex beasts with endless variations. Instead, by stopping yourself to ask, why does this even need to exist? You challenge scope changes and new additions to create a foundation versatile enough to be reused and expanded upon. By focusing on the basics and breaking everything down to its smallest parts, we were all able to align at each incremental step towards our shared vision. I also learned the importance of reusing what already works and connecting the dots, rather than having that designer urge to reinvent the wheel just to create something great. I'm mindful that this is a developer conference and we haven't really talked anything to do with code yet, so I'm going to pass to Will to talk a bit more about the implementation of these components.
Thanks, Josh. I think Josh has just explained and demonstrated exactly how technical a design system can be from the design side, but let's actually get technical with some code now and talk about how we brought this all to life. I just wanted to shout out a developer who was instrumental in bringing this project to life, Sean, who is not on stage with us now. Sean contracted with us for about 3 months and has built a lot of design systems in the past, and his knowledge was super valuable. So just wanted to give him a quick shout out. Thank you, Sean. Okay, let's talk about the tech stack. We did have early conversations around front-end frameworks that discussed Vue.js and web components, something like Quick or Lit, but Reese was really focused on the long-term maintainability of the project, scalability, talent retention. So React kind of ticked all the boxes for them, so that's where we ended up going. I think that's probably a familiar conversation with everyone in the room when it comes to tech discovery and landing on React as your framework of choice. Tailwind, obviously, the design system was built with Tailwind at the core. We knew that going in, so it's here. I really like Tailwind. I know it's controversial. Some people really hate it and can't stand it, but I am a fanboy, so we can have a fight about that later if you want. Come find me after the talk. I really like the composition that it allows and the utility-driven classes, so I think it's also really great for scalability in a large team. You have everything in line in the markup, but I do understand that you also have everything in line in the markup, so that can be problematic. Storybook was the final piece of our stack. We didn't really know where these components were going to live, so they had to live somewhere. If you don't know Storybook, it's a UI UX playground for technical and non-technical people. You can jump in and play with components on the fly and see how feeding different props in affects them. It was a brilliant choice for us in terms of design review with design, like Josh and his design lead Henrik, and other stakeholders on the team as well, to give them this sort of sense of progress. We used the TypeScript plugin to generate pretty much all the documentation we needed right from the props, which was also super helpful. I'd love to just sing its praises, but it's not perfect. It does crash. It crashes for us about 15% of the time when we load it up with very cryptic error messages, but that seems to just be the teething issues that you deal with when you are running with Storybook on a project. So we found the trade-off to be worth it. Josh, how did you find Storybook?
As Will mentioned, I think designers really enjoy working in Storybook because it gives us a visual representation as to where the progress of development is at. It gets us involved in the process a bit sooner on, which allows us to spot mistakes or issues and test out the variations because, as you can imagine, a design system is quite complex. So it's really important to make sure that the logic of what's done at a design stage lines up with dev.
Yeah, I'm glad it worked for that. Here's a little demo of me just changing some props on the fly. Just if you have never seen Storybook before, you've got a playground in the middle to sort of see the components, and you've got a control panel on the right, and you can document all your variants along the way. I'm going to talk about some of the technical challenges we face. Josh has kind of outlined this methodology for building UIs that is really based on a strong core component set that have lots of variants within them. And I suppose that was the first challenge, was solving this problem of applying variants. I have obviously just sung Tailwind's praises, but it's not exclusively a Tailwind problem, although its unique approach to utility classes does make things a little bit even more messy when you come to solve this problem. If you've written a component in React and other front-end frameworks as well, you've probably written something that's structurally similar to this. This is a button component here that takes in some properties of size and class names and some additional props that we're feeding in. We've got some base classes we want to apply, and in this case we have a size that can be small. If it's small, we want to use the small classes on the left of the ternary. If it's not, we use just the large classes. Obviously this is just one prop of size, and it's already looking a bit messy. At least half of the component code is just devoted to styles. We're jamming it all in an interpolated string, which is also not ideal. And then the more props you add on, you obviously start increasing complexity. This is just the color, and this is only one color, blue and not blue. So we have to start resolving this with a function, a different function for each variant. So this is not a new problem. Our button, though, has at least 12 different properties we need to handle. So we needed a solution to manage these variants. There are some popular libraries that help solve this problem. Class names and CLSX are kind of like your entry level. You can pass them an object and it will resolve the classes for you. CVA is a bit more fully featured. It is called the Class Variance Authority, which is maybe the scariously named library I've ever encountered in my time as a front-end dev. That is a bit similar to the solution we chose, but we chose a solution called Tailwind Variants, which kind of builds on CVA and adds a couple of features that CVA doesn't have that we found really helpful. I'll just show you a couple of examples to kind of get a picture of how this works. The heart, they're a little bit simplified, but bear with me. The heart of the library is this TV function. So you pass it an object that defines some base classes. In this case, we've got a button, so it's got rounded corners and bold font. Then you pass it a variance field with different variants that you wish to apply. So in this case, we've got a variant of size, and size can be either small or large. These keys can be strings, numbers, and booleans as well, and you can make it all type safe with TypeScript. I've just stripped all that out for the example. Then when you use this function, you get back a function. In your template code, you just call the function, and you pass it the properties it expects to receive, so the size in this case, and you get back a class string that you then apply into the variable. This is all sort of stuff that CVA supports. CVA lets you define variants and compound variants, but what CVA doesn't have that Tailwind Variants does is this concept of slots, which we found really powerful when we were building this. A slot is basically a way to break one variant down into specific slots that define areas of the component that you want to apply styles to independently. Probably makes more sense with an example. So here we have a card. This card has two slots. It's got a card slot that manages the styles of the overall card, and then it's got a content slot that manages the content within. And we can then write variants that apply independently to each slot. So for example here, the image padding changes the content but doesn't touch the state of the card at all, and individually apply each one of those when we finally construct the classes. So instead of receiving a single class string, you get back this object full of functions and you just destructure them and then you call them in line in the template. We found this a really powerful solution for building really complicated UIs that would fit the patterns Josh is talking about, where you have lots of variants that you need to manage, and it sort of centralizes it all in this one TV object. You have one file devoted to those variants, and you manage everything in there. Here is a live demo of me in Storybook playing with these exact props, the image padding and the corner radius. So you can see I can change the style of the card changes without touching the image, and vice versa. I can change the image without touching the card. You can also compose these classes that you get back. So you can get back a style class and then use that in another Tailwind variant. I can show you some examples of that after if you want to come find me. It's pretty noodly when you get into it, but it does mean you can create kind of complicated cards inside carousels and that sort of thing. The next technical problem we had to solve was custom colors. Josh, maybe you can tell me just why custom colors are so important for everyone in the design system.
You remember those annoying requests that I mentioned? Well, when you think about it, Reese is a house of brands, not too dissimilar to something like Maya. We've got some of the most established names in the home and trade space, some of which have hundreds of years of heritage. Naturally, there's an argument for maintaining that brand's look, whilst also keeping it consistently under the Reese banner. That's easy enough for us to do in design. We just apply a custom color, tweak the fonts, but it's less easy for you.
Yeah, I think the moment you add one custom color, you've added two custom colors, because you have to at least consider inverting the text when obviously a custom color gets too dark. And then you've got the potentiality for extensibility. How much is the client going to want to control these colors in the future? So we didn't want every component, every atom, every molecule to have to take a color prop that would then sort of drill down through the whole hierarchy. We wanted some sort of elegant solution that would prevent this. And we found it in a tweet from Adam, not to just throw more love at Tailwind, but Adam is the maintainer and creator of Tailwind. And he posted a tweet where he said, another pattern we use a lot is instead of conditionally adding classes, you can conditionally add a data attribute and just use that attribute to define and apply different styles. It cleans up the class string and doesn't have nested ternaries. We have solved that problem with Tailwind variants, but this was sort of the missing key in the colors conversation. So we use a system of, it's pretty simple when you think about it. There's just CSS variables and data attributes that we define at the top level. So in our Tailwind config, we have these custom colors that define sort of color layers of the design. So there's foreground, which is text. There's surface, which is the background of a card. And then there's the background itself, which is the background of the DOM, I guess. And then in our component, the top layer, we just define these data attributes that say, hey, if the foreground's light, I want you to change the text color to be some definition of white, or if it's not, I want it to be black. And we do the same when we feed in custom colors at the top level. And then we just access those data attributes in the variant. So we say if the foreground's light, make it light. If it's dark, make it dark. And we can manage that without throwing everything through. So that was an elegant solution that Adam provided for us that we definitely tapped into. And I think we are prepared for any future changes as well, because it makes changing components pretty simple in terms of the colors, at least. Those are a couple of the technical challenges. I just wanted to touch on design systems. I know Josh has done a pretty good job of selling in design systems for designers and stakeholders, but I think they also help developers. They definitely helped me when I was writing this project. I think you can't understate that idea of a shared mindset between design and dev. Gone are the days of getting like a single PDF that just says, hey, make this a website, thanks. I'll be back in 2 weeks to see how you've gone. Designers are starting to get into that mindset of building small blocks that are reusable, and that's exactly how we think about code when we write a React component, is to think about composability, making things as small as possible. So that really helps. For me, it made me write better code, more encapsulated code, because I know when you're writing a banner component and you know exactly how it's going to be used, it's really easy to make your component a little leaky because you know the edge cases that you're going to encounter. Obviously here, I'm trying to write atoms that compose to molecules that compose to components. I've got no context for how they'll be used, so that just reinforced good coding practices for me. So the design system sort of helped reinforce that. And lastly, that consistency of Tailwind in this example, but it could be any system you've agreed upon, between design and dev to give you that shared foundational language, and you don't have to constantly be chasing, was the border padding meant to be X or Y? Was the radius meant to be 10 or 12? So as a developer in this, on this project, my main takeaway was, as devs, we're the last ones in a long line of work that's been done along the way by, your researchers, your project managers, your business analysts, designers like Josh, and we're the ones who actually know how it works and make it happen, which is awesome. I think that's sort of what gets me up in the morning as well. But we also know how everything works, and that's a bit of a double-edged sword that we need to wield carefully, but honestly. We know how long it'll take to implement the carousel that the client has asked for, or the modal, or the nested modal. And that means we've got a responsibility to communicate honestly about the requirements and say, hey, that's going to increase our dev scope by 2 weeks. Is it really worth it? So everyone needs to be able to trust us when we come to the table and say it's not worth it. The second lesson I learned was, reach for a library to solve complex problems, Tailwind variants, for example, but also be careful how much you pull in. It's really easy to bloat your bundle, as probably everyone knows, and bring in stuff that you don't need. So really focus in on small solutions that solve complex problems rather than just bring everything in for the sake of it. Node might make that too easy. And finally, don't fight that design system, embrace it. So atoms, molecules, components, I think you'll move faster. I certainly was able to develop faster when I was working this way. So that's a bit about the technical challenges that we faced. We've talked about design, we've talked about development. We wanted to talk about both together. This sounds kind of obvious, but building this design system really taught us the importance of a strong relationship. That's not just about a good handover. That's about sharing a comprehensive understanding of this shared vision and journey that we're on, actively being involved in each other's worlds, becoming best friends, basically. That's kind of what this project was about. So we wanted to share the ways that we made this happen. On past projects, I think design and devs have been quite siloed off from each other. Our designers usually work with strategists and stakeholders to make some designs that suit business needs. Hopefully they also suit customer needs. That's not necessarily the case. We then have a handover, we go off, we dev all these designs. The designers might hear that we're working on something, but they don't actually get to actively review it until it's all done. And then they have to review a lot of the design all at once, and they're delivering feedback, and maybe the client's getting back involved. There's stakeholder feedback coming in as well, and we've got these revision rounds and 2-week sprints, and you're trying to get everything in before somehow at the end of it you get a finished website. Not an ideal way of working for either designers or developers. And on this project, we really had a strong core team that was the same all the way through, with some strong mentors as well, with Sean and Henrik on the design side for Josh. So we adopted this principle of over-communication. Like, almost it was a bit annoying to talk this much, but it was actually really valuable. We would build a component out as soon as we could, even when half the variant code wasn't in, and put it into Storybook and say, hey, how's this looking as an initial draft? Design would always be in there, seeing the latest builds and giving their feedback on the fly, rather than waiting for structured feedback rounds. I was in dev mode reviewing components. Josh and Henrik were in Storybook. Even they were in the browser tools, checking that everything was working the way they expected. So we were kind of talking all the time. And one of the main venues for this talking was, big groan from me as well, daily stand-ups, which I usually hate. I often think they're an exercise for their own sake, and some days I would dial in and I'd be like, God, another stand-up. I've got really nothing to say in this stand-up. But unfortunately, for the stand-up haters, which I would count myself among, they were also where we did really important work. I probably can't count the amount of stand-ups we had where someone would make some sort of offhand comment about what they were working on, and then kind of a dog down a rabbit hole, we'd be chasing this idea of a new component layout that we needed, or a new idea around custom colors or layouts. So I think those daily updates were really worthwhile for us on this. Just they're a tool that you use, and use them carefully, because they can be really annoying and a big mental burden as well. So run them as fast as possible, but leave space for evolving them. Josh.
Thanks, Will. With all that being said, true collaboration isn't just about talking to each other for the sake of it. It's really about listening and learning to understand each other to achieve the greatest collaboration possible. In our experience, there's usually gaps in the typical design-dev dynamic, which I know is a bit of a hot take. Designers, we often like to stay in our comfort zone. We like to leave the details of implementation to the experts. We don't always care how the sausage gets made. I hope everyone gets that Hamilton reference. But we just want to see the finished result and have it aligned to our vision. On the other hand, developers are really focused on execution. They care about the details. They build what's in front of them and prioritize the specifics over any abstract intentions behind the design. The problem with these two mindsets is there's often a lack of common ground, which forms a connection needed for real teamwork. In our case, we found that connection through uniting our focus on the concept of atomic design, with components that demanded both design flexibility and development structure. To bridge this communication gap, we set aside our preconceptions and learned to truly listen. We asked stupid questions out of fear, and believe me, I ask a lot of stupid questions, but we also stood firm on the non-negotiables that we need to do our own jobs to the best ability that we can. We both learned to pick our battles and compromise when we were creating pain points for the person on the other side. This really built trust and allowed us to communicate openly and honestly in a sort of help me help you way. We've each learned the value of approaching projects with open minds, balancing the confidence that we have in our own work and our role in the bigger picture with the needs and the value of others. By understanding what part we play, we can unite under a shared goal, putting our own personal egos aside to achieve something that we're all proud of. So before we wrap up, Will and I want to share you with one final lesson from our shared experience, and that is to share the magic. Whether you're a designer, a developer, or something else, we really encourage you to get involved in other people's worlds. Learn what inspires and challenges the people in your team, and find that shared goal and understanding. When working with a really detailed concept like atomic design, take the time to really listen to what everyone's interpretation of that is, and how they envision the pathway forward. Remember to be humble, and be open to being wrong. You're almost guaranteed to encounter bumps along the way, but stay fully committed to moving towards a shared vision. From our experience, that's how we found the motivation to achieve this monumental task of creating a design system for such a large organization. We really hope that these lessons help you to get up each morning excited to work with your team, excited to collaborate, and ready to get up and at 'em. Thanks for spending your morning with us. If you want to hear any more about the project, we might have some time for a couple of quick questions. But otherwise, reach out to either of us on LinkedIn or come find us after the talk. Otherwise, enjoy the rest of your day here at DDD Melbourne. Do we have time for questions? Yeah? Martin, I just want to circle back to your question before. Sorry, could you repeat it?
Right, so one thing that we've struggled with in design systems is the notion of donut-shaped components. Mm-hmm. So it could be a molecule or an organism slash component in your atomic design sort of language, where the component has a hole in it. Mm-hmm. And in Figma, they've got slots. You can't sort of put multiple children into it. The shared mental model we're looking for sort of breaks a little bit because React and Figma don't share the children concept in the same way. How did you work around that?
I'll speak from a design perspective first. The way that we structured it is by grouping the components and the layers in Figma, so clearly defining atoms, molecules, and components, we found made it a lot easier to swap out the instance level control of what's inherited inside here. So say, for example, if I've got a molecule and I've got a button, I can only swap that button out for other atoms. I can't swap it out for anything up the chain. So we introduced a certain level of control to limit the amount of customization where needed. And that extends to say we've got a component where at certain breakpoints or in certain instances, you wouldn't want to have a really large title. So while those options might exist in the code, it's about slowly kind of adding in Boolean controls or constraints so that what you're toggling won't ever break and that you're trying to account for as many situations as possible without the sky's the limit, and potentially having an endless scope, which makes it really hard to keep that control. Do you want to say something from
I think Josh also has built in Figma a lot of those components like prefab. So if you have a donut component, Josh has built in the design that other designers can come and take examples of those components in each level rather than having it as like a modular control. Because Figma just doesn't give you that level of control over the children. Yeah.
So around design system documentation, how did you manage the design system documentation, not the technical documentation like what's in Storybook, but more like the stuff around, do's and don'ts and I guess, elements / cross-cutting concerns? Where did that stuff sit?
It's a great question, and I think it's still sort of a work in progress. I think a lot of it is in the head of the design team. They know how it should be used, but as we start rolling it out across the CMS, I think there's going to be a big education piece around exactly what those restraints are. And even you can put all the restraints you want on at a code level, but the content editors are going to be able to make a broken component. So you kind of need to build those in at a higher level of governance, I guess, in a way. I don't know if you had more to add, Josh.
Yeah, I think exactly as Will said, it's going to be an education piece with any system of this size when it comes to rollout. The main benefit I think there is tracking your intention. So tracking why you made the decisions you did, whether that's in Figma comments, in Jira, which is something that we used as well, and having that version control where when components are changed, it's not just willy-nilly, no one knows what's going on, but actually utilizing features like Figma's dev mode so that the devs can compare the versions together and actually see what was the user need or the design problem that led to this component being changed in the first place.
Yeah, one more.
We're also in a very similar stage where we have a design system. It's developed pretty much using the same tech stack. One of the things that you mentioned around your core team and that's developing this as a product that other teams are using, we've had something similar. How do you communicate when you have new components coming out and new atoms coming out? And how do you then build that in their roadmap for adoption and moving away from what they have right now?
Yeah, that's a great question as well, and I think that's also a work in progress. We're publishing it now as a private artifact that other teams can consume, but that work is still sort of yet to begin, so we don't have a clear path to that in terms of managing change around that, and I think that'll be a big problem to solve moving forward, because it's, again, I feel like the hardest problem is not in the code, it's around the code.
Yeah. I think from a design way of working, it's never going to work if you approach someone with a new tool, a new system, and say, hey, we've got this as a replacement, just go and use it. What we have really been trying to do is bring people along the journey. And so when we've been educating the other designers and team about how to use the system, we actually take the time to sit down with them. We bring up a design that they've built either without components or using our old component library and gone through every step of how would you recreate this page using the new system? And I think having those practical examples of actually getting them involved in the space, getting them in your worlds, I think that's going to be way more beneficial because then they can actually see how it gets brought to life rather than you going away in a room making a decision that now impacts how they work. So bringing people along the journey is always going to be the best way forward.